Fundamentals. This is the first lesson of our set theory course. We want to look at some of the basic concepts and terms involving sets. Here's your checklist. Try to come up with your own example of a set, and then once you've done that, then try to find the size of the set in your example. Alright, let's begin the lesson. In math, a set is used to represent a collection, and this could be a collection of just about anything. But when we want to write the set down on paper though, we have quite a few options. So let's say we wanted to write a set containing the vowels in the alphabet. One option would be to actually describe the set in words. So we would write the set of vowels in the alphabet. Another option would be to list the elements individually between two curly braces. In this case, we would actually write out A, E, I, O, and U. The same goes for if we wanted to write a set containing all the months with 31 days. When we name a set, we usually give it a capital letter. So here I call the set of vowels capital V, but you could have just as easily used any other letter. For example, if you wanted, you could have called this the set capital A. Let's see some examples. On the one hand, we have describe it in words, and on the other column, we have list all the elements. So our first example is a set of positive integers. And these are 1, 2, 3, 4, 5, and so on. The second example is a set of numbers divisible by 5. And these are 0, 5, 10, 15, 20, 25, and so on. And just to show you an example without numbers, we have the set of names that end with A. For instance, we have Ava, Katrina, Anna, and so on. As you might imagine, different sets can have different sizes. The way how we determine the size of a set at this level is by counting all of its elements. In fact, we say a set is finite if you can count all of its elements. An example of a finite set would be the set of primary colors, and these are just red, yellow, and blue. Now suppose we want to find the size of some sets. To do that, we will count the number of elements, and this n here means the number of elements. So first up, we do number of elements in the set containing red, yellow, and blue. Well, this gives 3. Second, we want to find the number of elements in the set containing 10, 28, 193, 5, 0, -1, and 10. I'll give you a chance to count. And the answer is 7. Lastly, the number of elements in a set with nothing in it. And the answer is 0. Notice, however, that we usually write the empty set as this symbol over here. A set is infinite if you can never finish counting all of the elements. Examples of infinite sets are the odd and even numbers. Try as you might, the set of even numbers goes on forever, so you'll never be able to reach the end, and the same goes for the set of odd numbers. Thanks for watching. You can subscribe here if you want to get the latest from the Caribbean Scholar YouTube channel, or if you're ready, you can use the link in the description to hop onto our website and sign up for one of our premium courses.